Hello everyone, welcome to Ganit Academy. In this video, let us study about real numbers and their decimal expansion. So we have already studied about the real numbers. Like, what does it constitute? It constitutes rational numbers and irrational numbers. That means rational numbers, irrational numbers. Together, they form real numbers. And you know that on number line, every single point is a real number. Right, every single point will be a real number on a number line. So now real numbers, they are represented by capital R. Okay, capital R, that are real numbers. So in this video, let us see if we can use the decimal expansion of the real numbers to identify or to distinguish between the rational and the irrational numbers. So what is this decimal expansion? You know, 1.5, 1.25, 0.75, okay, 0.125, all these are decimal numbers. This is a decimal point. This is a decimal point, right? So these are decimal numbers. Decimal expansion, okay? It is a decimal expansion. So now let us see, based on that, how we can distinguish between the rational and the irrational numbers. So what are rational numbers? Rational numbers are those numbers which can be written in the form of P by Q, where P and Q are integers and Q not equal to 0. So then what are irrational numbers? Irrational numbers are just opposite to rational numbers. So these are numbers which cannot be written in the form of P by Q, which cannot be written in the form of P by Q, okay, and Q not equal to 0. So this is also called as a ratio, right? See, the rational number in the rational, that, okay, there is a term ratio. This is a ratio, means numbers which can be written in the form of ratio are rational numbers. So ratio, and we can also call it as fraction. Okay, fraction. This is a fraction. 2 by 3 is a fraction. 1 by 2 is a fraction. It is a ratio of two numbers, 1 and 2. Okay, so these are rational and irrational numbers. And we know, like pi, I have already said you pi, okay, that is your irrational number. And Euler's number E, this is also an irrational number. And I told you square root of 2, square root of 3, square root of 5, square root of 7, square root of 8, square root of 11. These all are irrational numbers. And I had said you in the last video to remember one point, that all roots are not irrational numbers. All roots are not irrational numbers, because if you consider the square root of a perfect square, that means square root of 4. 4 is a perfect square, right? 2 square is equal to 4. So square root of that 4 is equal to 2, and 2 can be written as 2 by 1, which is a ratio rational number. Okay, so all square roots are not irrational numbers. Then if you have a prime number and if you are taking the square root of prime number, then it will be an irrational number. And not necessarily it should be a prime number. You can have some other numbers like square root of 8. 8 is not a prime number. So square root of 8, this can be written as square root of 4 into 2. So square root of 4, square root of 4 into square root of 2. So what is the square root of 4? It is 2. 2 root 2. So 2 root 2, it is an irrational number, right? Because there is a square root of 2. Okay. Then we will take these three numbers and we will see how to find the decimal expansion of these three fractions. Okay, three fractions. So 10 by 3. So now we know that this is the divisor. 3 is divisor, 10 is the dividend, right? So 3, now I'll take this. I will take the form of division now. So 3 3s are 9 and you have 1 as remainder. So you know 1 is not divisible by 3. So what I will take? I will take the decimal point. Then I can add a 0 here. So 3 3s are 9. Then again we have remainder 1. Once again it is not divisible. So 10, 3 3s are 9. Again we have remainder 1. Once again 10. So 10, 3 3s are 9. Okay, 1, 0. And again I will take 3 here. It becomes 1, 9 and remainder is 1. So this goes on. Every time it is continuously repeating. You can see 10, 9, 10, 9, 10, 9, 10, 9. Once again if I take 3 like 0, then again it will be this one. So what happens? This goes on. 3.3333 it goes on. Okay, it goes on. So in this fraction, we can see that first remainder is 1. Remainder is 1. Okay, next remainder is again it was 1. Again it was 1. And again it is 1. Again 1. Right? These are the remainders. And 1 is continuously it is repeating. Okay, that is remainder. And here we can see 3 is continuously repeating. Okay. And now we will take another fraction. We will check and we will conclude some points after finding the decimal expansion of these 3 numbers. Okay. So next we will take 7 by 8. So now again I will take 8, which is a divisor. Take the dividend here. Then 7 is not divisible by 8. So what I will do? I will take 0 point. So now I can add a 0 here. So 8 8s are, it is 64. Right? 8 8s are is 64. Then what is the remainder here? It is 6. Right? It is 6. Next, once again, 6 is not divisible by 8. Take a 0. 60 and 8. 8 7s are is 56. Okay, 56. And now the remainder is 4. Remainder is 4. 4 is not divisible by 8. So 40. So 8 5s is 40. So now the remainder is 0. Now the remainder is 0. So in this case, 7 by 8, what is the answer? 0.8759. What are the remainders? What are the remainders? First it was 6, right? Then what we had? 4. Then it is 0. It is stopped. It is terminated now. The remainder is also 0. Okay. Next. Next we have 1 divided by 7. Let us see what will be the answer for this. 7, and here I am taking the dividend. Now once 1 is not divisible by 7, so what I will do? Point. Okay. So 7 ones are 7. Once again the remainder is 3 here. 10 minus 7 is equal to 3. Next 3 is not divisible by 7. So once again 30. And what is the nearest one? 7 4s are 28. 7 4s are 28. What is the remainder? It is 2. Once again it is not divisible. 20. 7 2s are 14. 7 2s are 14. Now the remainder is 6. Now once again it is not divisible. It is 60. I will continue the calculations here. 60. 7 8s are, it is 56. 60 and 56. What is the remainder? 4. And now once again 40. And what is that? 7 5s are 35. Okay. Now remainder is 5. So once again it is not divisible. So 50. 7 7s are 49. And now we have the remainder 1. And once again not divisible. We have same thing now again repeating. After this once again this steps repeats. That means after 7 once again I will get 1. Then 4. Okay. So I can write 0.142857, 142,857, 142, and it continues. This process continues. Why? Because we have got 10. So now it is nothing but it is starting from the first step. Again this repeats, and once again we are going to get 1 as the remainder. Again the process continues. Okay. So now we can say the remainder here, remainders for 1 by 7. So first remainder is 3. Next remainder is 2. Next remainder is 6. Next remainder is 4. Okay. next is 5 and 1 and 1. Okay, now again it starts repeating. It starts repeating. So now I will erase this. See here, in this first fraction 10 divided by 3, what happened? The remainder, it is repeating. In the next 7 by 8, what happened? It terminated. And here in this part, what happened? Again it started repeating after some set of numbers. So what we can say is, in decimals we have two types. One is terminating decimal. Another one is non-terminating decimal. Non-terminating decimals. Terminating decimals, non-terminating decimals. See this 3.3333, once again it is continuously repeating. That means it is not terminating anywhere. So that comes under non-terminating decimal. This is non-terminating decimal. What about 0.8759? It has stopped. It means it has terminated. So 9 is the last digit here. So this is terminating decimal. Terminating decimal. Okay, this is terminating decimal. Next we have 1 by 7. What happens is 142857, 142857, 142857. Again it is repeating. So this is also not terminating. So it is non-terminating decimal. So in these three, only one is terminating, other two are non-terminating decimals. So these are the two types. And once again, in the non-terminating, we have two more classification. One is recurring, another one is non-recurring decimals. Okay, recurring decimals, and another one is non-recurring decimals. Non-recurring decimals. So we will see what is this recurring and non-recurring decimals. So here what happened, after the decimal point you have 3, 3, 3, 3. Once again if you want to fill the next digits, it will be 3, 3 only. So that means the digit 3 is reoccurred. Okay. That means after 3 again you have 3, 3, 3, 3. Reoccurring. Okay. But here what happened? 142857, 142857, 142857. So if you want to find out the next digits, easily you can tell, you can say 142857. Again it will repeat. The set of numbers or the string of digits, it is repeating itself. So this is also recurring. This is also recurring. Then what is this example of non-recurring decimal? You can think that, right? So non-recurring decimal. Okay, let me take an example here. Pi. Say 3.1415926535. Is it repeating itself? Any set of strings is repeating, or any particular digit is repeating one after the one continuously? No. So you do not have any string of digits. You do not have a single digit which is reoccurring. So we will consider this as non-recurring decimal. So it is non-terminating because it's not terminating itself, and it is not reoccurring. So it is non-terminating, non-recurring decimal. Non-terminating, non-recurring decimal, and that comes under irrational number. So here we considered 10 by 3, 7 by 8, 1 by 7, which are all in the form of P divided by Q. P divided by Q. That means rational numbers, because here the denominator is not 0. Okay. So it is in the form of P by Q, and Q is not equal to 0. So these are rational numbers, and we saw for the rational numbers what type of decimals you have obtained. So one is non-terminating, but it is recurring decimals. Non-terminating, recurring decimals. And here it is terminating decimal. Terminating decimal. And here non-terminating, again it is recurring decimals. Okay, non-terminating, recurring decimals. terminating decimals. These belong to rational numbers. Rational numbers. Okay, so we will take an example. We have I have written all these things here. You can see the patterns. Okay, patterns. See, pi is 3.141592. I said that not a particular digit or a string of digits is repeating here. So this is an irrational number. Then Euler's number, that is also an irrational number. But why? You can see the decimal expansion 71828188284. There is no particular string of digits repeating itself. So this is also an irrational number. Then what about 22 by 7? 22 by 7, it is 3.142857. Once again, it is continuously, okay, reoccurring. That means here you can see the string of digits repeating itself. 142857. String of digits repeating itself. So it is not terminating. Obviously, it is not terminating anywhere. Okay, because your remainders are continuously reoccurring there. Okay, after 7, once again you have the remainder, same thing which was earlier. Okay, so there is a string of digits repeating. So it is non-terminating but recurring. So that is rational number. So 22 by 7 is a rational number. Next is square root of 2. So that is 1.414213,562,373 and so on. Once again, we cannot see any digit reoccurring here. We cannot see any string of digits reoccurring here. So this is also an irrational number. And we already know square root of 2 is irrational number. Next comes 9 divided by 7. So 1.285714, 285714, 285714. That means you can see this particular string, it is reoccurring. That is reoccurring. So once again, it is non-terminating, but it is recurring decimal, So that is nothing but it is rational number. Then what is 4 by 9? Again, it is in the form of P by Q, and let us see the decimal expansion of that. It is 0.44444. You know how to find the decimal expansion, right? Take 9 divisor here, take 4 here, and it is not divisible, so point. Then you have 40. So what is this nearest one? 9 4s are 36. Then again you have remainder 4. So now it is repeating. See, remainder is also repeating. It is not terminating to 0. Okay, it is repeating. So here also it is repeating. So this is your rational number. Recurring, non-terminating, recurring decimal. Okay, either a single digit or a string of digits should reoccur to call it as non-terminating, recurring decimal. Next here, 15 by 9. Okay, this is once again a fraction. So by seeing that, I can tell that it is a rational number. But let us see the decimal expansion. Now they have not given you the fraction, but they have given you the decimal. Now you have to tell whether it belongs to rational or irrational. See, 1.66666. So if you want to fill out the next digits, it also 6666. Okay. So now once again, this 6 is the digit which is repeating itself. So this is once again non-terminating, recurring decimal. So this is a rational number. Next comes square root of 3. Okay, you know square root of 3 is irrational number. See the decimal part. 7320508076. Once again, there is no string of digits or a particular digit reoccurring. So this comes under non-terminating. Why? Because it is not stopping anywhere. It is continuously, okay, continuously it is progressing. So it is non-terminating and it is non-recurring. Why recurring, non-recurring? Because here it is not repeating itself. So this is irrational number. Next is square root of 8. 2.82842714247461903. Once again, you cannot see any string repeating or any digit repeating. Digit repeating means it should be continuously like this, 4, 4, 4, 4, 4. If you have 8 here, somewhere you are getting 8, that does not come under repeating. Okay, it should be continuously repeating one after the other. After one after the other, it should be repeating. Then only we can call it as recurring. Okay, next is 556895 divided by 6. This is an integer, this is an integer, and denominator is not equal to 0. So now we know that this is a rational number. So let us see the decimal expansion. 92815.833333. Once again it is increasing. Like not increasing, it is continuously progressing. 333333. Okay, so this digit, you can now tell me, like, okay, here we saw all these were like 0.4444, 0.66666, 0.33333. Okay, there was no other digit before that, but here you can see before 3 you have 8. Then you might think, okay, whether it is a rational or irrational number, whether it is recurring or non-recurring. This is recurring. If you have a digit, single digit, and then after that if something is repeating after a particular digit, then also you can call it as recurring decimals. So this is also recurring decimal. So this is a rational number. Next, here also you can see 9.1, then 66666. Okay, so here the digit 1 is there, but it doesn't matter. It is recurring because after that everything is 6. Right? So this is also recurring decimal. So 50 by 5 by 6. So 9.16666 and continuously 6. That also comes under rational number. Okay. So then comes Euler's number. We have already seen. So this is how we will find out the decimal expansion of a particular fraction. So if you are given with the fraction, you are going to divide this. Okay. You are going to do the division method. And then you are going to find the remainders. Okay, check whether the remainder is becoming 0 anywhere, or whether the remainder is repeating itself, or the particular string is repeating itself. And one more point to remember. See here, this string, if you want to see this string, okay, 142857, there are 6 digits. 6 digits. Okay, there are 6 digits and divisor is 7. Remember, divisor is 7. Here 3, 4, 5, 6 digits. Divisor is 7. Divisor is 7. And here the number which is repeating is only 1 digit and the divisor is 9. Divisor is 9. So the number of digits in a string, okay, number of digits in a string which is reoccurring or repeating, that will have, okay, that will be always less than the divisor, value of the divisor. So here it is 7, this is 6 digits. Okay, it is less. Number of digits is less than the divisor. And single digit also you can say. Single digit means number of digit in the string is 1 only. Only single digit is repeating. So divisor is 9. So obviously this digit, number of digits is less than the divisor. Okay, here it is 6 digits, 1 digit less than the divisors. Okay, and so you can say the decimals, if the first case you can consider remainder if it is equal to 0. Remainder if it is equal to 0, then this are considered as rational numbers. And decimals will be terminating decimals. Terminating decimals. Why? We will see. 1 by 2, example 1 by 4, 1 by 8, all this you can consider. So 1 by 2, you know 2 divided by 1. So it is 0.5. Okay, 0.5. Here the remainder is 0. That means it is terminated. This is the first case. Remainder is 0. And the decimal, it has stopped. Okay, so it is terminated. Terminating decimal. 1 divided by 4. So it is 2. Then you have 8. Then you have 2. Okay, 5. Then you have 20. Here the remainder is 0. So the remainder is 0. And the decimal is 0.25, which is terminating decimal. Terminating, after 5 you do not have anything. 0.25, terminating decimal. So these are examples for this first case where remainder is 0. Okay. Next you have remainder not equal to 0. Remainder not equal to 0. Remainder not equal to 0. In this case, you can have recurring decimals. You can also have the non-recurring decimals. So, recurring decimals, non-recurring decimals. See, I'll consider this 0.4444, which is, again, if you want to find out the next digits, it will be 4. So instead of this, what I can do, I can write 4 and bar above that 4. Bar above that 4, that means this digit is repeating. Okay, 0.4 bar. If you want to write this 1.2857, 142857. Okay, so 28574. Okay, this is repeating. So what I can write 1.285714, and I can write the bar above these digits. String of digits which is repeating. String of digit repeating, above that you can write a bar. If a single digit is repeating, it is 0.4 bar. Here 9.16 bar above 6. Bar above 6, that means 6 is repeating. Okay, so these are examples for the remainder not equal to 0, remainder equal to 0. So in this case, remainder equal to 0, that will be a rational number only. But in this case, you can have rational or irrational number when the remainder is not equal to 0. And when the remainder is not equal to 0, check if it is a recurring decimal. If it is recurring decimal, it is rational number. Okay, rational number. If it is non-recurring decimal, then it is irrational number. Okay, irrational number. So, finally you can write the flow chart. Finally write down the flow chart. Decimals. In this you have terminating. Terminating, that means the remainder is equal to 0. Remainder equal to 0. And then you have non-terminating. Non-terminating, where you can say remainder not equal to 0. Remainder not equal to 0. Once again we have recurring and non-recurring decimals. Non-recurring decimals. So here obviously this is a rational number. This is a rational number. This is rational number. But this case it will be your irrational number. So example, you can consider something like 3.14152 something, okay, which is not repeating. Here you can write 1.333333, 0.3333 and so on, 0.44444 and so on, 1.285714, 285714, okay, and so on. Because here the particular string is repeating, here a particular digit is repeating. Okay, so terminating 0.5, 0.25, 0.125, okay, and so on. So these are terminating decimals. So this is all about real numbers and their decimal expansion.